Hello, hello, hello. Hello, hello, hello. Are you out there? Good morning. Good morning, good morning, good morning. Welcome, welcome. Hope everyone's having a good day. Everything should be operational. Morning, Edgar. Great to see you in the digital realm. So I'll wait for others to appear. How about this? All right, let's see who's out there. Only Edgar. I like it. I hope you're doing well, Edgar. I will wait for others to join us. It's Friday. We don't have too much time left. Today we're going to be reviewing. I have to clarify one of the questions that I went over from the last class. Let's see where everyone else is today. So we'll wait. Okay, let's use that. Oh, hey, good morning, Liana. Good morning, good morning. Hope everyone's doing well. We'll wait about another minute, then I'm going to go right to it. Hey, good morning, Gianni. So I read your exciting event. I think you said that you moved to Jersey, which is pretty cool. Do you have the date of our test yet? I have a meeting today at like 1 o'clock, so I'll have an update hopefully by the end of the day. Thank you for asking, Liana. All right, so while we wait, I'm going to go right to the whiteboard. Can you just make sure that it's working? I have the word of the day today. What is the word of the day? Out on the street. Can someone please check that the board is working? Once we confirm, then I'm going to go right to it. And I want to just clarify one of the questions, and then we'll look at other questions. And while you do that, I'm going to post the solutions to this review sheet, all of them. People are showing up. Landscaping. And yes, I moved in with my sister. It's been good. That's great, Gianni. Awesome. So I hope you know that the reason why I choose these words, it's just because of what's happening in my environment right now. So I hear people mowing their lawn. The landscapers are going nuts right now, so I chose that one. I was going to say lawnmower, but I don't think it was a lawnmower. It's another gardening tool or landscaping tool, so whatever. I know, very exciting stuff. Extremely exciting. All right. So I want to share the solutions now to the review sheet. I'm going to post that in our classroom so you can have it. Okay, so we have the solutions. They're going up. So that will be live in like a minute, not even. Who's that? Sarah, good morning. Okay. All right, so if you check the classwork section, you are going to have uploaded the solutions to this. People are joining us. All right, check it out. It should be live. Check it out. Can just someone confirm that it's there? So again, I posted the solutions if you can just please check. Now, while you check that, I wanted to go over one of the questions that we went over the other day. It was that trig question. I had to clarify it just because my understanding of it was just thrown off a little bit. The procedure was fine. It's just the value that we labeled one of the sides. I just wanted to correct that so this way you have the correct information. Is it out there? Do you see the solutions? Anyone out there can confirm that you now see the solutions posted in the classwork section? It should be in the final exam review material section. Good morning, Josh. I just need one person to confirm that you now have access to the solutions to the review sheet. So while you do that, I'll quickly go over the question that we went over on, what was it, on Tuesday. Oh, it's up? Good, thank you, Josh. Great. So here's the thing. So we have to find the length of the wire, but if this is the whole wire contraption, let's say, so this is the ground, right? I'm just highlighting the ground, and this is your tower. Here's the tower. This wire, it'll start from here, and it'll go up, and it'll attach to the tower, but it'll only be high by this many feet. And I believe that the degree measure was 47 degrees. So basically the only issue or thing that we have to change is the value or the height. I think I incorrectly gave you a height of 300. Should have been 200. So I think that'll make it a little bit clearer. It's still the same procedure. It is cosine. And I believe this is number, let me just look here. I'll go to the review sheet. What number were you? Oh, 38, right? So it's cosine of 47. This was 38. This is just a clarification to that. And if you solve, I think it's about 293 feet, something like that. So again, it's just a clarification to number 38. So if you can just take a note of that. Everything else was fine though that we discussed from the other class. I'm going to use the comments that you left from the last class that we discussed, and then we're going to go over some questions from there. So again, for those of us that are joining, or for those that are just joining now, I have no solid date yet on the final exam. Hopefully I'll find that information out later today. I have a meeting to attend, so stay tuned. But it should be at some point next week. And please continue to study. There's 38. Yeah. All right. Okay, so looking back now at the comments from the last class. Seems like everyone got a haircut too, or a good number of people. Almost done with Final Fantasy X. Excellent. I love it. Great game. All right, so where were we? So looking back here, we looked at 38. We looked at 26, I want to say. I think we did that one. Let me just look at what we have. Right, so 26. Yeah, we looked at that one. Let's see which other one was bothersome. 26 and 27, 26, we looked at that. Those were the high ticket ones. Seems like 27. It says here, a rectangular field along a river is to be fenced with 800 feet of fencing. Find the dimension of the field which will produce a maximum area. So we can look at that one shortly. But I want to make sure that, so if there's any questions here, please post which questions you want to look at, because some of these questions could take a bit, and I don't want to spend like 45 minutes or a half hour going over one question. I want to make it, worthwhile to the group while we're here. Let's see. No one? So again, I asked if you wanted to go over specific questions here on the side. I'm just waiting for you. If not, then we'll look at this question in about 30 seconds. Okay. So there's no specific questions. Do they still remain the same from the last? All right, so let's see. Alrighty, so let's look. All right, so continuing. Time permitting, I'm going to go over that last one. So it may take a little bit. So let's see what we wrote here from the last class. Okay, let's look at 42. Let's look at this. So how about this? Any questions from 1 to 10? While we're all together, any questions from 1 to 10? So if we look at 1 to 10, there's just, inequalities. That could definitely appear on the exam, the absolute value. I have a feeling that we may need some clarification with the absolute value. So why don't we do that? Because that's definitely going to come up at some point. Strong feeling about that. Why don't we do 3F, just to make sure that we have that. So if we look at 3F, we have something like this, right? The absolute value of x divided by 5 minus 2, all of this equals to 3. So this is the whole thing, right? So something to consider. So the value, right, it could be negative or it could be positive when you're actually evaluating an absolute value, for lack of better words. So what we have to do is we have to consider that we'll either have a positive outcome or a negative outcome. So that's one of the things with absolute value. So when you're solving this, you have to consider both a positive and a negative outcome, because when you plug that into the value, ultimately the end result is going to be positive. So we have to consider both of those instances. So if we were to solve, so we have x over 5 is equal to 6, and then x over 5 is equal to, in this case, negative 1. So if we solve, then we should have what? 30 and negative 5. And this is what, 3F? Oh, my mistake. It's plus 2 over here. So this should be positive 5. So again, if we solve, I'll go through the solution process again. I know it's a little bit elementary, but again, solving over 1, cross multiply, x equals 25, x equals to negative 5. So hopefully that's a little bit clear, because this has appeared in the past, and I just wanted to make sure that at the very least you know how to solve something like that. All right. So why don't we look at any clarifications with inequalities and expressing answers in interval notations? Would you like to look at that? I just want to make sure that we have that down. So why don't we do something like this? Why don't we do something like 4e as an example? So 4e, I'm going over this because, again, it's something that I've seen in the past, and I just want to make sure that we're prepared. So 2x minus 3, the absolute value of this, minus 5 is greater than or equal to 6. So we have here basically the following. So what we have to do is we have to consider both the negative case and the positive case. So just take a look at that for one moment. But here's where it's going to get tricky. So again, because when you're multiplying, so think about this. So if we're considering the negative case, right? We're going to have to now switch the direction of the sign. And this is where this gets very tricky. So here I left it in the original direction on purpose because when we're dealing with inequalities, we have to change the direction of the sign when we're either multiplying or dividing by a negative number. But here, we're not doing that necessarily. It's not direct, but the fact that we're manipulating the inequality now to have this negative component, it has to be altered. So again, if we have an absolute value inequality that we need to solve, we have a positive case and a negative case. So the negative case must change the direction of the sign. So once we do that, then you can just solve this as you would a normal inequality. So this becomes 2x is greater than or equal to 9, and then we have 4.5, x is greater than or equal to 4.5, and then here we have what, 2x is less than or equal to negative 3, or x is less than or equal to negative 1.5. But now you have to write this in, you have to write this in interval notation, I believe. So writing this in interval notation, so it could be a little bit tricky. Could be a little bit tricky. And what number is this again? Let me look here. This is 4e. Did we forget something here? Oh. So my mistake. It's Friday. I forgot about this 5. My apology. So I'm going back, I'm clarifying. So I'm just going back here. I forgot about the 5 that we had before. So again, it's one of the issues with the board. I keep moving it, and I keep missing some things that are happening. So I'm just clarifying the work here. So here we have a final answer. So hopefully you found this in your work. So let me just go back and highlight here. So what needed to happen was this. So we had to add 5 to both sides, and then we get 11 there. But remember, it's the negative case and the positive case when you have the absolute value. So then therefore, what's going to happen is this: when we solve, hopefully you have that x is greater than or equal to 7 and x is less than or equal to negative 4. But you're asked to write this in interval notation. And you did this already when you were looking at the domains and the ranges of certain functions. So hopefully you rewrote this as the following, right? Because it's going in positive direction or towards positive infinity. So hopefully you translated it to the bracket 7 comma infinity and then the parentheses, or it's open when it's going in the positive direction. Over here, since again we're including, right? We're including negative 4, but it's going, since we're going to include negative 4, but it's in the direction of negative infinity. But to express this in proper interval notation, we cannot leave it like this. Because if you think about it, you put this on a number line. I'm going to do this very quickly. If you put this in a number line, this is what it looks like. so you get better perspective. So here, we're including 4, but we're going in this direction. Here, we're including 7, and we're going in this direction, right? But there's this empty space here. So things are not happening in here, which is fine because we don't want to include any of the green. So what we need to do then is the following. We need to say, all right, we're going from negative infinity, or we're going in that direction, but we stop at -4. We then resume again at 7, and we're going all the way to positive infinity, but to express this in proper notation, it's the combination of these two values, or domains, if you will. So what we need to do then is connect it with a U. And I think we looked at this before. This is the union. So I'll put this in parentheses. It's the union of these two sets. So the set of values from negative infinity to -4, inclusive, and then the set of values from 7 to positive infinity, inclusive. And again, this letter U, it's a symbol for union. So you're just combining those efforts, or those values. All right, moving along. Okay, so let's see what we need to do here. So why don't we look at an example like 8. So someone had a request to look at something like that. So what we need to do, and this I've seen in the past also, so we should definitely know how to do something like this, and we should look at it this way. So here we have f of x plus h, right, minus f of x, all of this divided by h. I could have sworn that we did something like this almost recently. Let me just charge my battery, just give me 1 second. So remember here, so I think the example that we have here, right? So here we're going to look at letter B, a little more complicated. So we have 3x squared minus x minus h, right? So this is our f of x. So what we want to do, it's not 3b, it's 8b, sorry. So what we want to do now is evaluate this function using this difference quotient. So basically we're going to be evaluating. So wherever we have x now, when we have x plus h, it becomes something like this. 3 times x plus h squared minus, right, x plus h minus 6, right? But then we have minus f of x. So this is where you need to be careful. And this you should zoom out a little bit. Because if we're going to subtract all of f of x, right, we have to put all of that in parentheses. So what's in parentheses exactly? 3x squared minus x minus 6. So all of this gets divided now by h. So we have to evaluate now. So the trickiest thing to evaluate here is going to be the following. It's going to be this x plus h. That's probably the trickiest. So If we look at that separately, so this evaluate, remember, it's x plus h times x plus h. So again, we FOIL this, x squared plus xh plus xh plus h squared. But remember here, this becomes x squared plus 2x h plus h squared. But if you go back, right, you have 3 outside of the parentheses. So it's 3 multiplied by all of this. So this now becomes 3 times. Let's see here. Good morning, Zaid. All right, welcome. Okay, so now we have to distribute this 3 into all of this here. So then this becomes 3x squared plus 6xh plus 3h squared. I know it's a lot. I'm zooming out because now I'm going to include the rest of what we have to do here. So don't forget, so that's just evaluating the x plus h part, which is squared, and all of that multiplied by 3. Now I have to include everything else. So I think zooming out, you'll get a better picture now of what I'm going to do. So now remember, we still have minus x minus h. So we have to be careful with that, right? Because it's minus, right, x plus h. So I'm just distributing that. This becomes minus 6. And I have to distribute that negative, right? I'm going back to the original expression. I'm distributing the negative into the parentheses, so it becomes now minus 3x squared plus x squared, right? Or plus x, excuse me. And this becomes plus 6. Okay. So look at what happens here. All this, don't forget, all of this is divided by h. Just so you know, all of that is divided by h. So I'm zooming out again because this numerator is like crazy. So I'm going to highlight what we can get rid of, or the like terms. So here, let's see, what else? I'm going to color what we can get rid of. Not minus h, excuse me. Minus 6, and then this plus 6. So whatever I just boxed is going to disappear now. All of that is gone. Okay, so I'm going to now rewrite what we have left over. So 6xh plus 3h squared minus h. All of this now is divided by h. So hopefully you see it. It's pretty clear that we can divide out or factor out an h in this numerator. So here, here, and here. So if we divide that out, so it becomes h times 6x plus 3h minus 1. All of this divided by h, but you can cancel out the h, and then you're left with this as a final answer. So that was 8b. So hopefully that's clear. All right, going back now, let's see. Are you good with systems of equations? So again, now I'm looking at questions from 10 to 20. I'll look at a question like 9 next week for sure. Again, we're meeting every day next week. The exam is still to be determined. I'm going to find out later today. Most likely next Friday, I'm guessing. So again, I was available on Wednesday. No one messaged me for office hours. I'll continue to be available also next week during office hours. But if you just need to go over extra stuff, I can make myself available one-on-one. It's just a little bit tough. I'm typically free like later in the day, like 6, 7 o'clock. But I don't mind, helping you out during the day if you have like a quick question that needs to be answered. But if you want something like this in addition to, the Monday and Tuesday, that's going to be Wednesday, and I'll be free again from like 7 to like about 8ish or so. Okay, why don't we look at this coin question? A jar containing 26 coins. I think that could be interesting, right? So here's the thing. So there's 26 coins, right? And it represents dimes and quarters. That's an A. Right? And in total, you have 26 of these coins. But the value of the coins, I'm disregarding the unit of measure here, which is dollars. I'm not going to include dollars. So if we add this up, it's going to be a little bit different, right? So we have $3.50 worth of dimes and quarters. But remember the value of a dime, right? It's 0.1 or 0.10. Remember the value of a quarter, plus 0.25. So now this is the system that you basically have to solve now in order to answer this. So now the question is, how do you do it? So we could do this a number of ways. If you want, I don't want to confuse further. I definitely don't want to confuse you further. We can eliminate. We can do substitution. There's many, processes that are involved in solving this type of equation. But what I want to do is I want to eliminate, and I think it may be safe if we multiplied. It doesn't really matter which variable you want to get rid of. The only thing that makes this tough is the fact that you have decimals. So let me do this quickly. Yeah, I want to do it through elimination. So if we're going to do the following, we're going to multiply everything on top. So what I just circled now, we're going to multiply that by negative 0.10. Oops. So the entire top equation is going to be multiplied by this. So then it becomes this, negative 0.10x minus 0.10y equals negative 2.6. Sorry for the sloppy handwriting here. But now we're going to combine this with the original equation, which was, or with the other equation, excuse me, which was the following. It's 350. Okay, so clearly here, this eliminates. So I'm just going to focus on what gets eliminated. Gone. And everything else now we can reduce. So this should be 0.15. And then this becomes what? So again, this would be positive, right? But now when we divide, we should have a y value of 6. But what do we label as y? So let me just zoom out again. So what do we label as y here? Y, we said it's quarters, right? So we have 6 quarters. So these are quarters. But if we go back to our original equation, x was dimes. So here, x should be, 20. So when y is 6, then this is what number here? 14. So again, this is the work for 14. So we had 6 quarters and 20 dimes. So the reason why I went over this, because it's a good review of system of equations. I would imagine that there's going to be probably at least one question related to this, but it was also good to see it in a way where you had to basically transform or rewrite a verbal expression here or these word problems into a system of equations. So I wanted to practice that as well. And also setting up variables. So if you just go back to the beginning of the problem, right? We had to define what x and y were. So we labeled dimes as x and y as quarters. And we knew that when you added those two together, you would get 26. But the values combined, right? So when you combine those, dimes and quarters, it equals to $3.50. So to solve, right, there's methods to do this. You could substitute or eliminate. We went through the elimination method. We got rid of x. We isolated y. We found the value for y. So it's just a little bit hard to see the decimals. Sorry about that. But when you end up dividing this and isolating y, you have a y value of 6. And that represents, again, quarters. And then if you substitute that into the original equation of x plus y, you can clearly see that you'll have 20 dimes. And you could always check your work as well. All right, so you have the solutions. That has been posted. If you want to review any particular question on your own, you can do that. You can come with fresh questions on Monday. I'll go over whatever questions you like. That's number one. Number two, I'll try to also have the review focused. I should have more information later today related to the exact date of the final. When is it? I don't know yet. Definitely before, I think the last day of college now is like the 12th or the 14th, but the final exam is definitely a few days before that. So, the earliest may be next Friday, I'm guessing, but I'll keep you informed. Hopefully I'll find out later. And once I find out, you'll know. Any questions? Okay, so if there are no questions, on that note, you see that? 45 minutes went extremely quick. I know that. It's not a lot of time. We're going to do the same thing again on Monday and Tuesday, but I'll make myself available Wednesday morning. Available as early as 7 a.m. I know for some of you that may seem, very early, but that would have been the office hours that actually were the office hours that I had to adapt to now, right? Because I, switched out of academy. So that was the reality before all this happened, and we're going to maintain that now. But I am flexible. If you have any question, if you want to, go over a specific question, you can email me, and I'll try my best to work with you one-on-one. But if you want like another group review, you want me to go into detail, pull out the whiteboard, I can do that an extra day next week, and that day will be on Wednesday. And again, the office hours I'll have will be between 7 and 8 o'clock. All right, so if there are no more questions, that's it for today. Have a great day. It's the weekend. I hope you enjoy it. And I'll see you again on Monday. Until then, be safe.